and welcome to my YouTube channel, where every episode I take a physics topic and hopefully explain it in a really simple and understandable way. Now some episodes are just going to be fun physics facts, but most I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. In today's episode, I'm going to be covering terminal velocity. I think a brief introduction to velocity might be required first. So we all know what speed is, right? It's how fast an object is moving, aka how much distance is covered in a certain time. It's calculated using the equation speed equals distance over time, and it has the SI units of meters per second. Speed is a scalar quantity. Now to learn more about this, please check out my episode on scalars and vectors. Now, there is an equivalent vector quantity for speed as well, and this is called velocity. As it's a vector quantity, velocity has both a magnitude and a direction, so it's a certain speed in a given direction. Therefore, it will still have the SI units of meters per second, but it will be accompanied by an arrow or a description of its direction. There you have it, that's velocity. Thank you so much for listening. Oh wait, you guys want to know about terminal velocity. Right. Now this will go a bit smoother if you've seen my episode on friction. Eh? See what I did there? Anyways, just briefly, friction is a force that always acts in the opposite direction to movement. If you're travelling at a steady, constant speed, in other words, there's zero acceleration, then the driving force will have to be equal to the frictional force, and therefore they'll be balanced. So friction occurs when two objects are in contact with each other, or when an object is moving through a fluid. The latter can also be referred to as drag. Now, two examples of drag are air resistance and water resistance. We can reduce drag by making things more streamlined, but once again, this is covered in more detail in my friction episode. But one thing that I did not mention in that episode is that frictional force increases with speed. So like a motorcyclist going at 60 miles an hour will have more air resistance to work against than a normal cyclist at say 15 miles an hour. However, this increase of friction with speed only occurs up to a certain point. So when an object begins its descent through the sky, the force of gravity is greater than the resistance slowing it down, so it's accelerating. But as the velocity increases, the friction builds up. This resistance force builds up so much that it reduces the acceleration until eventually the frictional force is equal to the accelerating force, and therefore there is zero resultant force. At this point, the object can't accelerate, so the velocity will remain equal to the resistance. It's here that these balanced forces means that the object has reached its maximum velocity. And we call this maximum velocity terminal velocity. Now, did you know that squirrels are rare in that they can actually survive impact at their terminal velocity? This means that no matter what height you drop a squirrel from, it will probably survive. How funny is that? We should put it in a spacesuit and drop it from low orbit and see what happens. I know, silly idea. But we need the spacesuit because otherwise it would burn up or freeze to death before reaching the surface. Now, just to finish up, an object's terminal velocity depends on its shape and area. If it wasn't for air resistance, then all objects would have the exact same acceleration rate due to gravity. However, due to air resistance, objects fall at different speeds, and their terminal velocity is determined by their drag compared to their weight. There we have it, terminal velocity. Thank you so much for listening. I hope you enjoyed it. If you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I'll try to do a video for you.